The Master of Science in Electrical and Computer Engineering program at CMU-Africa is for students who aspire to become engineering leaders through hands-on training in the African context.
The world runs on energy. Most of the industries, or all industries we see around us, are powered by energy. And so energy engineering and power systems in general is relevant to industrialization in Africa. And I think that's the starting point for sustainable development growth in Africa.
Building a strong community of electrical and computer engineers across Africa is critically important for the development of the continent because electrical engineering touches a wide range of topics from the power grid all the way to automation, transportation, and many of the systems in telecommunications, for example, that make the economy grow, creates jobs, and also provides the basic needs of citizens in many cities and also in rural areas. And so electrical engineering is key to designing those systems and also finding the right combination between hardware and software that solves the problem in a very efficient and cost-effective way.
Our MSECE students are exposed to a wide array of topics, which include nanotechnology, robotics, energy and embedded systems, computing and networking, biotechnology, and more.
The faculty on campus bring a wealth of knowledge from both academic and industrial perspectives, and this exposes students to real-world material. Some of the skills I developed at CMU-Africa included being able to solve problems from multiple angles and break them down into smaller bits to come up with a holistic solution. And also because of the multiple team-based assignments and group projects that were part of our courses, I developed collaboration skills and the ability to work well in a team.
The master's program in electrical and computer engineering at Carnegie Mellon University, and particularly here in Kigali, Rwanda, aims at training professionals that are not only deeply technically capable of understanding, the technology, but also are able to deploy it in the real world. And so that means that our students have a wide range of opportunities to learn the fundamentals, for example, of signal processing, of circuits, of all types of electrical components and machines, but also develop the software and the algorithms that are required to then make these systems work in the real world.
At CMU-Africa, students are exposed to cutting-edge technologies in our state-of-the-art lab facilities, testing their knowledge gained in the classroom on real-world applications.
Given that the students have a very solid understanding of both the theory and practice of electrical and computer engineering, their career opportunities are very broad as well. So they can choose to go and work in an established company, be it in the power sector or in the telecommunications or in industrial automation. They can also choose to continue towards a PhD and develop new knowledge in electrical and computer engineering or another adjacent area. Last but not least, they can also choose to start their own companies, and sometimes part of their work and their research activities lead to new discoveries that allow them to develop new products and new systems. And we help the students through our various entrepreneurship and incubation opportunities also to bring those products to the market.
As part of the coursework, there was the opportunity to work on hands-on projects in the lab. One example will be the power electronics course, where we were introduced to power electronic devices in the lab and interacted with them alongside other circuit components for utility usage.
Our world-class faculty and practical approach to education gives students the tools to develop innovative engineering solutions across multiple disciplines.
The CMU-Africa community is diverse, filled with staff, faculty, and students from all over the world, especially students from all over the continent of Africa. And this exposure gave me the opportunity to think more about diversity and inclusion, and also consider diverse approaches to problem solving given different cultural contexts.
In terms of critical thinking and how we get our students to exercise critical thinking problem solving, what we do is that we very quickly initiate our students into problem solving. I'll give you an example. When we teach any course on programming, for instance, we tell the students that we are not teaching them to program. We are teaching them how to use programming to solve problems. And so we equip them with the skills, for instance, that enable them to determine which are the most optimal solutions for these problems.
With the diversity of skills and real-world experience our students gain at CMU-Africa, our graduates are prepared to tackle Africa's most pressing technological challenges.
CMU-Africa develops leaders by providing a rigorous curriculum that allows students to think outside the box. This is seen in the coursework where students are presented with application projects and given constrained resources to come up with solutions to them. This is typical of the challenges we face in various African communities where we have complex, multifaceted problems and constrained resources to address them. This prepares us to be leaders that are in touch with our communities and bring a socio-cultural context to the kind of solutions we provide as engineers.
Do you want to be part of the next generation of African tech leaders? Earn your master's degree from one of the world's leading engineering universities, right here in the heart of Africa. Visit us at cmu.edu/Africa.